Hello viewers, welcome to Differential tutorials. I'm Mr. Amos. Today we want to look at, or want to continue with solutions to the non-separable ordinary differential equations as we did the last time. The last time we were looking at the either homogeneous equations, also known as the non-separable ordinary differential equations of first order. So today we want to take another example so that we can build our understanding more on solutions to non-separable ordinary differential equations. So the question says that find the general solution to x y prime equal to y squared plus y. So we have x y prime to equal to y squared plus y. Kindly note that in some versions of the question could be stated as y prime is equal to y squared plus y all over x. In some cases, the question is stated as this, whilst in some cases, the independent variable x would be t. So when it is t, then the question is stated as solve y prime to equal to y squared plus y all over what? T. So whichever version of the question, it doesn't matter. So we want to look at how then do we find a solution to this particular ordinary differential equation. Okay, so as we learned previously, to solve this ordinary differential equation, what we do is, or to solve the non-separable ordinary differential equations, what we do is we make y prime the subject. And so I have y prime to equal to y squared plus y all over x. So I make y prime the subject. That's by dividing both sides by what? X. So I have the derivative of y to equal to y squared plus y over x. And then what I do is, the next thing is to divide. We have y squared then dividing what? X. Then we have y dividing x. And so y squared dividing x can be written as y prime to equal to, so this can be y over x times y. Then adding to y over x. So at this point, we have been able to rewrite the equation into a form where we have y over x. Now kindly note that from here, where we have y over x times y, that is this. If I want to send it back to the original form, I will multiply the y by the y. So I have y squared then over x. So it basically stays the same. So having expressed it as this, so what we do is we say let u to equal to y over x. So if u is equal to y over x, then we make y the subject, so that we have y to equal to what? U times x. So that is, we make y the subject from y u to equal to y over x. And so the derivative of y, that is from here, if we differentiate the y, we are going to have what? So and the derivative of y, that is y prime, is now going to give us 1. We apply the product rule to differentiate this particular function. So note that the y, which is equal to u times x, is made up of a function of u multiplied another function of x. And so by the product rule, we differentiate u and maintain x, then we add it to maintaining u and differentiating x. Note that if we differentiate x, we are going to get 1. So 1 times 2 will give us 1. But because the u is a function of y over x, differentiating the u will not give us 1, but rather we need to put the derivative sign on it. And so, having done this, we now replace the y prime, which is this, for the y prime here. So putting y prime as this into this one, so we have the equation to then become y prime of x, u prime of x plus u, that is for the y prime here. Then replacing it for this, and it will be equal to, so this equation now becomes y over x was represented as what? U. So we have u times y, then plus u. U multiplying y times u. Note that this y over x was u, and then this y over x is u. But there was already a y there, so that's why we come here. Now we now have the equation in terms of three variables. We have u, we have x, and we have y. That is not too appropriate. We need it in terms of new variables. So that means we have to transform the y again into a function of u and x, so that the equation becomes a function of u and x only. And by doing that, we know y to be equal to u times x. So putting y as u times x, the equation becomes the derivative of u with respect to x plus u to be equal to u multiplying u times x. The u times x is for the y, which was here. And so we add it to this u. So the equation becomes u prime times x plus u to be equal to u squared times x plus u. U times u will give us u squared. And now we group like terms by sending the u to this side. Study the equation, you will now know that the equation has now been transformed into u and x. And so at this point, the equation has become separable. So we want to now separate the x and the u variables. And so we have u prime of x to be equal to u of x, u squared times x plus u, then minus u. And so we have u prime times x to be equal to u squared times x. U minus u will give us 0. So we have it this way. But note that we have x and we have x here. So if I divide both sides by x, then the equation then becomes what? U prime to be equal to u squared. And so at this point, we have been able to separate the variables. But the u prime here is what? Is the derivative of u with respect to x, because the independent variable in the equation is x. And so we have changing the u to what? Derivative of u with respect to x. So this will give us u squared. And then we multiply both sides by the x. So we have the u to be equal to u squared times the x. So now we have the u to be with the dx. So we need to bring the u squared to its side. So we divide both sides by u squared. Dividing by the u squared will give us 1 over u squared du to be equal to what? Dx. But we can rewrite the 1 over u squared as u raised to the power negative 2 du to be equal to dx. And so, having separated the variables like this, we have the u's at this side and the x at this side. We now take the integral of both sides. So integrating this side, we have integrating u raised to the power negative 2 with respect to u to be equal to the integral of 1 with respect to x. And so the integral of this one will be adding 1 to the power and dividing it by 6. And so this side too becomes integrating 1 with respect to x will give us x, then plus the constant of integration c. And so this side becomes u raised to the power negative 1 over negative 1 equal to x plus c. Moving forward, this becomes negative u raised to the power negative 1 equal to x plus c. And so the power is a negative, so taking the reciprocal or changing the power to a positive power, we are going to have negative 1 over u to be equal to x plus c. But note that the u, as we started, was equal to what? Y over x. So putting y over x here, we have negative 1 over y over x to be equal to x plus c. And so taking the reciprocal of y over x gives us x over y negative to be equal to x plus c. That is from this negative, the negative 1. And so we can multiply both sides by y. So therefore we have negative x to be equal to what? X plus c all multiplying against what? Y. So when we do this, we can make y the subject by dividing both sides by x plus c. And so we have y to be equal to negative x over x plus c. Hence, y, which is negative x over x plus c, is the general solution. So we have y is equal to negative x over x plus c to be the general solution to the non-separable ordinary differential equation given to us. So dear viewers, this is all about solutions to non-separable ordinary differential equations. Kindly share and subscribe to my YouTube channel. Thank you.